The last concept that we've got for section 3.3 is condensing of logarithmic functions. So this time we're going to take our big expanded version and we're going to condense. So for the first one right here, the ln of x plus ln of 7 minus the ln of 9, we are adding the first two pieces, which is applying the product property in reverse, and then we are subtracting, which is applying the quotient property in reverse. So my first step is I'm going to apply the the product property, moving from left to right. So ln of x plus ln of 7, the product property would be the ln of 7x minus the ln of 9 is left over. And then I can apply the quotient property, which is the ln of 7x divided by 9. The subtraction turns into division. My second expression here, I've got a power property as well as a quotient property. You can see here the 4 and the 2 are going to be raised up, and then I can simplify. So here let's start by bringing our powers up. When we condense, we do the power property first, and then the product and quotient going from left to right. So first thing, ln of x minus 4 raised to the 4th minus ln of x squared. And then I can see I can apply my quotient property where this first quantity is going to be the numerator, the second quantity is going to be the denominator, written as a single natural log. So the natural log of x minus 4 raised to the second, actually this should be raised to the 4th, over x squared. The third one that we have here is we've got a power property outside of the brackets. So we'll start by simplifying inside the brackets first and then work our way out. So this is one of those times you want to do inside the parentheses first. So here log base 3 of x plus log base 3 of x minus 2, that right there is a product property. So I can rewrite inside my brackets log base 3 of x times x minus 2, and this whole quantity is inside parentheses. Now I can raise that expression to the 1/5, log base 3 of x, x minus 2 raised to the 1/5, and then finally I can rewrite that as the 5th root. Of x times x minus 2. And yes, you can distribute that x in if you'd like. The last example we have here is the ln of e to the 6th minus 2 ln e to the 5th. You notice that there's no x's in this, so we should come up with the final answer. So we can start out by taking our 2, and we're going to roll it up here applying our power property. So we've got the ln of e to the 6th minus ln of e to the 5th raised to the 2nd, which is ln of e to the 6th minus the ln of e to the 10th. ln and e's are inverses of each other, so using the inverse property, we know ln of e to the 6th is going to be 6. ln of e to the 10 is going to be 10. And since we're subtracting the two quantities, it's subtraction. So 6 minus 10 is negative 4. I see two common mistakes I just want to clarify. Most common mistakes, and I've already mentioned one of them, log base 4 of x plus 7 does not equal log base 4 of x plus log base 4 of 7. This is not a true statement, so we cannot say that those guys are equal. You cannot distribute a log. No distributing of logs. The second thing that I see a mistake made on is not checking bases. In order for me to do any of these properties, the quotient or the product property, I need to have the same bases. So here, log base 4 of x plus log base 5 of y is not log base 20 of xy. The same bases are needed if you are going to apply those.